Hi, everybody. Welcome to another Hoss Talks Foss. I'm Matt Yonkovit, Percona's Hoss, here to talk Foss with Sergey and Jobin, two of our key support engineers here at Percona who have been working on all kinds of awesome things in the Postgres space. And we wanted to catch up with them and talk to them a little bit about some of the work that they've been doing and some of the recent conversations they've had and presentations they've done. Hi, Sergey. Hi, Jobin. How are you guys doing?
Hi, we are good. How are you?
Good, good.
Yep,
Sergey?
I'm doing quite good. Thank you for inviting. Thank you for the
Yes.
invite, basically.
So, you two have been at Percona for a while now, and you've been doing quite a bit around the Postgres space. And so, I wanted to ask you just off the bat, and this is a conversation, so take this where you want it. What kind of interesting things are you starting to see from the people you're working with from a Postgres perspective? Are there interesting, trends you're starting to see and topics that are popping up?
Yeah, majority of the people currently are migrating from proprietary databases like Oracle. So they are getting trained in terms of the open source and open source culture and how the open source works. So many times the conflict of culture is more. Say, Oracle provides everything completely packed, but when it comes to open source, we assemble pieces. Yeah.
So so people, in other words, so people are expecting kind of this, really polished UI and everything just to work together, and they might need 3 or 4 different projects that work together.
Yeah.
And that's where they're running into issues.
Yeah, even when we say the high availability, we recommend this particular framework. Then say they are coming from a world where they have only one choice, but we we have n number of choice for everything. Say backup, at least half a dozen backup tools are there for Postgres. Yeah, so then we choose the best and give okay, this works, should be working perfect for you. Yeah, then that's
Yeah,
that.
and I mean, choices are good, but they're also paralyzing when you're not used to them, right? So
Yeah.
it's very difficult, to make that choice. Now, when we talk about, whether it's high availability or backups, typically we have a recommendation, and that recommendation, what is that?
Yeah, we recommend and we extensively use Patroni for the high availability solution, right, Jobin?
Yes, yes.
And for the backups, our preference is PG Backrest. Although
Right.
we actually do support a few other tools as well. And I actually wanted to pick up on what Jobin said previously because I actually switched from Oracle to PostgreSQL in 2015, and I was in the same position as a lot of people are now, and so it is like actually beneficial for me at the position I have right now to have walked a walk like 5 years ago. So switching from Oracle, like you have an RMan, right? But then on PostgreSQL side, you have barman, which sounds similar, but is not RMan actually, right? Then you have PG Backrest and quite a lot of different projects. And then there are forks of projects. The WAL-E was rewritten as WAL-G, and it's an excellent project, but everything is, yeah, it's a bit of it's a bit of open source in the good and the bad that entails. Like the documentation might be lacking sometimes, and you have to go and try the waters basically quite a lot. Yeah, but so far in the last 5 years and 6 years, the infrastructure and everything, every project matured, and it's like right now, I think it is easier than ever to do the switch.
So you mentioned PG Backrest, right? So from a backup tool perspective. Now, you also mentioned we support other backup tools. Now, is that because, customers just want to use a specific backup, or are there specific use cases that one tool is better than others?
Yeah.
I believe you can.
Yeah. Yeah. So the PG backrest is is there around for some time. It's matured and it is widely used. And that has some features which is not there in other tools. But the other backup solutions are addressing certain specific areas. Say for example, the cloud integration was very good in. That's what the ValG was originally targeted. But the PG backrest was targeting on the real enterprise users, Oracle-like customers. Yeah, so that's a an entirely different approach. But now what we are seeing is all the tools are coming to a common domain of expertise. Say the PG backrest is gaining the cloud integration step by step. Now they have Azure and Google Cloud support. Yeah. So
Okay.
yeah.
So what you're seeing is each of these different backup tools have different feature sets, but slowly as they mature, the feature sets are getting integrated between the tools. So there becomes less and less differentiation.
Yeah.
Now, Sergey, coming from the Oracle space, let me jump back to that because this is an interesting perspective that we don't normally get here because a lot of folks who I talk to are been in the open source space for 10, 20 years. Now I come from an Oracle background, way in the back. So I mean I remember those days. I have I think PTSD and I shell shock from when I had to handle those cases and those issues. But as a former Oracle DBA and as you're talking to these folks, besides the issues that just understanding, hey, this open source is different than a single vendor controlled project, are there some technical things that continue to kind of like worry or are hard to grasp for Oracle DBAs kind of coming over to this space?
Yeah, absolutely. For PostgreSQL especially, like the way, like getting real technical, the way Oracle and PostgreSQL work with memory and the disk and everything like that, they are deceivingly similar. Like you have the WAL files, it's like the redo, right? And you can archive them, and it's all pretty similar. You have a buffer pool, but now the checkpoints are not really similar, right? The I/O profile that the database generates is completely dissimilar, and you just cannot go and give all the memory to PostgreSQL, whereas you could probably pull that off with Oracle, and a lot of people do and did. So yeah, just from the like sending queries perspective, those are quite similar. But then when you start kind of applying real pressure to PostgreSQL, things start to crumble a lot. And conceptually, they are different. Like the MVCC model is completely different. With the vacuum that is jarring for a lot of newcomers in PostgreSQL. Like it's not bad, it's not good, it's just different, right? It's completely different from anything that anyone expects who didn't work with PostgreSQL before. So yeah, coming from Oracle, it's a bit of a as I experienced it, it looked similar, right? So I actually switched to MySQL later, and I mainly work with MySQL right now. So MySQL is quite different. It's different from Oracle, it's different from PostgreSQL. And PostgreSQL seemed to be similar to Oracle in a lot of places, and logically it was similar. But now there are a lot of details, like a lot of fine print that you have to understand, that you have to fully grasp. So yeah, that is can be a pretty steep hill to climb.
Yeah, and I think that, one of the things that I've seen over the last few years is the number of people who are looking to do that migration. Jobin, you said this is probably the biggest area that we're seeing is the growth in migrations. They're choosing Postgres because it's similar. And does that lead to people then making this assumption that, like, I've lifted, I've shifted, maybe I've rewritten some code, but it should just work like the same, and all of a sudden you go from, hey, I was able to handle 15,000 transactions a second, now I can only handle 5,000 because I didn't tune it right or I didn't properly, do certain things? I mean, is that what we're seeing?
Yeah. First of all, the first part of the question, what is driving the migration? Of course, the overlap. Say, Postgres is claiming to be the most feature-rich. So we'll get more overlap with the Oracle in terms of stored procedures and functions, say the PGSQL, which we have in Postgres, is somewhat similar to Oracle's PLSQL code. So and we have very rich data types. So all those things are driving the migration. Selection comes automatically to Postgres. But yeah, the surprises like something which was working in Oracle is working poor in Postgres. That's a very common problem, and that happens when we move from Oracle to Postgres, or if we move from Postgres to Oracle, because these two things are entirely different. When we have an application which is fine-tuned for Oracle, and if you just take that code and put it into Postgres, uh, that may hit on some other edge cases. Like Sergey mentioned, the MVCC is one major difference. So in Oracle, we have this undo area where they move the old images to an undo space, and that's how they manage their MVCC. But in Postgres, we leave that on the same place. The old versions are left on the same place where the data is stored. So the consequence is the inserts are fast. So because insert don't have to do anything, it is create another row and put it there. But the demerit of this approach is the updates are costly. The updates is nothing but insert and delete. So the things which works in Oracle world may not be that efficient in Postgres, but there are areas where Postgres excels in, say especially this insert kind of load. And yeah, we are seeing lot of applications where they have complex architectures, and say when they write very complex queries, they tune that query for Oracle, say views and queries on the top of views, and over a period of time they might have recorded multiple times and optimized that query for Oracle. Some way it is working there, okay? And when we take that complex piece of code and put it into Postgres, surprise comes. Yeah.
I gotcha. So okay. So it is different,
different.
and you do have to
it.
tune it and make sure that it's optimized. And one of those things is making sure that you're using the right indexes, because obviously the indexes between what's in Oracle and what is in Postgres are going to be different. And this gets back to your Percona live session that you just gave, which is talking specifically about the power use of indexes in Postgres, and kind of giving that user perspective, because there are many different indexes available in Postgres right now, and each one of them has a very unique operation, and a unique thing that they're trying to solve. So maybe if you can give us maybe the quick overview of that talk, like what did you talk specifically about, and people can find the talk so they can watch the whole thing online, but give us that quick snippet of what people can expect if they go watch that.
Okay, so as we gave the talk, I started talking and Jobin picked up, so I guess we will follow suit here. And the talk, we mainly targeted maybe audience who is not really experienced with PostgreSQL, and we gave an overview of indexes, trying to give specific examples where you would like to use them. For instance, while preparing and while working on this and while discussing with Jobin, a real highlight of the talk for me was the cache index, which was for a long time like an ugly duckling in the PostgreSQL world, because it was not wall logged, it was not replicated, it was not crash safe. Like it was okay, you could use it, but you were documentation told you not to. And like from PostgreSQL 10 onwards, it works perfectly. Like it's fine. So yeah, even if you know indexes, even if you think you know indexes and you know PostgreSQL, sometimes it's worth revisiting basic stuff.
So let me ask you there, right there. So okay, I come from the MySQL space, and there's a lot of people who aren't familiar with the Postgres index types. You mentioned the cache index. You mentioned it's not crash safe. You mentioned that you can't replicate, right? So there's a few things that like right away you're like, oh, I never want to use that. But then you said, oh, but 10 on, it works. So you have to explain now the cache index and what it does and what the benefits are, because, now I'm left hanging, and I will go, listen to the session, other people will, but let's give them a little preview here.
Absolutely. So the hash index is applying the hash function to an entry, and it's really simple in that what it does, it allows you only a single operation, an equality operation. Like, it only indexes for the something equals something, right? And the benefit here is that while it is limited in the use case, it actually has a peculiar property that the hash function always produces a uniform length of a key. Like, if you give it half a tome of War and Peace, it will give you 122 characters. I don't know how many exactly, but still, like, imagine that you are indexing something where you have URLs. Maybe people's names are not a good idea, but URLs, right? URLs can be lengthy. URL like blog post and database of blog posts, right? Crawled. And you probably are not going to look for URLs with the larger than operation, right? So the HTTP google.com is not larger or smaller than yahoo.com, right? But you want to look for a specific record, and the hash index will be compact, it will be fast, and it has a pretty low overhead of the inserts as well compared to B-tree. And yeah, so pretty interesting. Like a good addition to the portfolio of indexes that you can use. Again, from the 10 onwards, but given PostgreSQL 10 is 4 years now, probably everyone should check it out.
Okay. Sorry, I needed to stop you because, you mentioned it, and wanted to get everybody here to listen. So you talk about hash index. I thought you said cache, but it's hash. So, my bad speakers here. So from a hash perspective, that's useful information. But, there's also, your gist indexes and your gin indexes and B-tree, which everybody knows B-tree. It's kind of the standard in most databases. So, you're going to go through and you're talking about these different indexes and how they're used. And so, this is an important topic, but people just think I add an index and I'm done. Is that the case? I mean, is there any more thought process than I have this in my where clause and I'm going to go ahead and, index it?
Yeah.
Right. Yeah. Jobin, if you may, absolutely. The default index, as you mentioned, is the B-tree, and the more data you add to it, you cannot expect it to perform as well as it performed before. And especially if your data profile, let's put it like the data distribution changes for no reason or for maybe unexpected reasons, you suddenly may have a really suboptimal index. And the B-tree index has a couple of tricks in its sleeve. It's not really specific to B-tree, but you can build partial indexes covering only some keys, right? But you definitely, even if you are just indexing and expecting everything to work, and it works, like with the NMVP, an early prototype, when you get real data, you might want to consider different indexes, and so you need to keep an eye on that. And I believe Jobin will mention a few other indexes that are could be useful.
Like Sergey started. So normally people just create an index and say, I have an index, but they're not really worried about whether that's the right choice they made. Like Sergey mentioned, the partial index, that really works wonderful in many cases. Actually, Sergey showed a demonstration of how it can be optimized. So because that can have a where clause, the index itself. So only certain criteria will be used for creating an index. So the index size will become small, and so especially the status codes and things like that. That's really great. Yeah, and coming to the specialized indexes. So the database are general purpose, right? And like Postgres database. So we need indexes like text indexing. This is altogether a different area of specialization. So the general B-tree index may not work there properly. So yeah, so the Postgres gives this GIN kind of index. That's a totally different approach to the indexing. The keywords are extracted and they create that is indexed. Yeah, that's a
So that's like a full
yeah,
text
yeah,
index, like full text searching to search a block of text for a keyword or two.
And any the beauty of the worldwide community is anywhere in the world, if there is a research going on about some better indexing, the first choice for implementation could be on Postgres, because it's open and free, and somebody want to try that on the Postgres. So we have a lot of these kind of index implementations. So the Bloom index is something really interesting, because yeah, it's yeah, and yeah.
So what tell us what the Bloom index
Yeah.
is. What is that?
Yeah, so
optimized for?
like Sergey mentioned, the hash index, it prepares one hash, but the problem with the one hash is it can be used only for one column. The one column need to be hashed to one value. But what about the multi-column index? Say multiple columns need to be indexed, need to be hashed. So the Bloom provides that feature. So it is similar to signing on the top of another signature. So we'll have a very complex signature. So once we have that complex signature, very easy to map with the actual data. And the beauty of this Bloom index is that the order of the column is not important. Generally, we have the problem with the B-tree index. B-tree index, the first column, second column, and third, like that. The order is important, right, in the index, because that's how the B-tree is prepared. But this Bloom index, because it is a hash function, the order of the column is not important. So these are the specialized indexes, solves specific purposes. Yeah.
And so I'm guessing that the Bloom indexes are following the Bloom filter.
Yeah.
Right? So yeah. Okay, that makes sense. Now let's take a step back and let's speak to those who aren't necessarily DBAs, in the space here. So I have just started a new application. I've chosen Postgres as my database of choice, and so I built this application. How do I go about? What should we do to find what needs to be indexes and what indexes should be used? Like, how do I start there? What are the tools, and walk me through some of those decisions or some of the things you might look for and recommend people do in order to find, which columns need to be indexed and which is the appropriate index.
Yep. Well, ideally, not ideally, but if you are only writing to a database, more likely than not that you might not need any indexes at all, right? So it all actually depends on the retrieval of the data. With PostgreSQL, you don't need a cluster index, right? Like MySQL would probably need. So you just have heaps of tuples, and you can insert and insert and insert forever, and you don't actually need indexes. So you shouldn't start with your tables and columns. I believe that you should start with queries, right? So you have specific access patterns, you have specific queries that hit the database. Like maybe if your application is doing some kind of a login and it needs to get a page with your customer profile, which it gets by an ID from a user table, right? Then probably that user table needs an index on the ID column, whatever the index type may be. How would you approach learning which columns need to be indexes? Well, again, I firmly believe that you should start with queries, and PostgreSQL provides built-in facilities for looking at slow queries. Right, Jobin?
Yeah.
So you can set up logmin duration statement, correct me if I'm wrong, to, I don't know, maybe to 0, like do a complete query audit.
Yeah.
Or you may use, or you may, I don't know, poll pgstat activity, right? Or you can set up pgstat statements, like a really popular extension that just does all the analytics for you, and it will break down the queries and give you the max duration, maximum duration, average duration, right? If you are brave and if you want to try new things, you can try pgstat monitor from Percona, right? It adds a bit of more new features to the idea of pgstat statements. And you can actually go ahead and try PMM, which builds on top of the data from pgstat statements or pgstat monitor to give you a more of a polished UX experience to your queries in your PostgreSQL database. Like the other talk I prepared for Percona Live with other support engineer was about usage of PMM for PostgreSQL, so you may want to check it out. But yeah, I mean, from my point of view, you should probably start with queries, right? Yeah, Jobin.
My approach also will be similar. Say little more aggressive in that nature. Avoid Postgres, avoid indexes wherever possible, because.
Well, wait. I almost heard him say
sorry.
Postgres. So I wanted to correct that. Yeah, no. Don't avoid Postgres.
Postgres is great. Postgres is great. Avoid indexes wherever possible, because what drives that is people first look into the scheme and start designing indexes for that, but without realizing that the indexes has its own cost. So as we know, it actually slows down the transaction processing because indexes also need to be updated by OLTP, the inserts, update, deletes, and the problem won't stop there. In Postgres, the indexes also need to be maintained by auto vacuum, and the cleanup need to be happening. And the indexes also need to be there in the cache in memory for a better performance. So it occupies memory, and it is associated disk IO will be there. So there is a cost associated with indexes. So try to live without index if it is necessary. Yeah.
But wait. So are you suggesting so what you're saying is zero index? So you're at. Well, so I mean, I think there's an interesting, discussion here, because I can see the process of when you're doing your application, you're developing it. There's not a lot of data, so the performance isn't necessarily going to be needed in a test environment. So I can see going zero index there. So would the process then be, collect your, query log, like you mentioned, Sergey, doing a query audit and setting it to zero, like the threshold, so collecting everything, and then analyze that and then see what indexes you need based on that? Or are you saying move to production with no indexes and let's just be the wild cowboys that we are, because we love to test in production? Where do you fall on that, Joe? But what scale do you fall on?
In production also, when we collect the customer information, we have an analyze script, and we see that there are normally we'll see hundreds of indexes which is never used, because the analysis report comes with a zero usage. So those are the areas where we can go the other way. We can remove indexes which is not used in real production, and save space and memory and things like that. At the same time, we have this problem as well. So the creation of index is kind of a continuous tuning. So the things which used to work earlier may not work later. So the index requires a continuous monitoring, and the schema need to be optimized. Even simple B-tree index may later need to be converted into partial index kind of. So it requires some kind of like Sergey mentioned.
Okay, so start with very few indexes, if any. Do some tuning to figure out what you need, but realize that this is an iterative process, and what you needed yesterday won't be today, because we all know that we totally love to go back and remove things that we added before, and we just don't leave them sitting there. I'm being sarcastic. Of course we do. What technology out there doesn't have, some weird code that you're like, I have no idea why that's in there. And I think that applies here as well. So as you implement new features, as you implement new indexes, as you go down these rabbit holes to tune, every release cycle of a new application changes the access patterns, which means that, what indexes are being used or not being used could change at every release cycle. And with the continuous integration and continuous, deployment, that happens now, an index you used yesterday might not be used tomorrow, but it might be used 3 days from now. And that presents kind of a weird challenge, right? Because, you have these evolving, indexes. So I don't know, maybe we need to figure out, the automation to build and remove indexes on the fly as needed or something. I don't know. But it is an interesting space, for sure. So Sergey, you're in favor of indexes. Jobin hates indexes, it sounds like. He never wants indexes ever again.
We should follow an approach of minimal viable index, right? So just do as little as possible, but not less than it would be, messing up with your performance. But I definitely see, and I saw in practice, and I created redundant indexes, right? You can never anticipate, unless you are dealing with a pure IoT, I believe, stuff, then you will probably not anticipate the amount of data that will grow and how exactly it will grow and where it will grow, right? So the databases, they evolve, and trying to optimize for that trying to optimize for a database that is sized in terabytes when you have 10 gigabytes of data is probably not something that should be done. It is a bit premature, and definitely the issues will arise. But
isn't there a trade-off here? Because I'm thinking from the user perspective, or those who are unfortunately tasked with managing these large systems in production. The question is, as you start to see these, applications grow, adding indexes takes time, and it actually makes performance problems worse. So, there is some trade-off here, right? Where it's do I index early, hoping to get ahead of those problems, or do I wait until I need it, knowing that when I need it, it might cause a bigger issue than what's happening in production right now?
Yeah, absolutely. There is a fine line. I don't think there is a silver bullet approach here. Absolutely. I don't think that you should go live without any indexes at all, right? I don't hate indexes. I'm not joking. But he also
Jobin hates indexes.
Yeah, but let's take the other extreme. You take every column, every data, every table in your database, and you index every column and every combination of columns in both orders, right? So you will have a lot of indexes, but you will probably not have a quick database, right? So what I think should be to comment on the situation that you described. You should probably try to not end up with a situation where you have a burning production and that you have to kind of extinguish with an added index, right? So with the continuous integration and with the continuous delivery, there should be continuous monitoring as well, right? So you should probably be keeping a finger on whatever is happening with your database, right? So are the queries kind of changing? It's a sort of a living organism, right? It's growing all the time, and it evolves. Issues will happen, absolutely. Maybe tomorrow you haven't anticipated a release, and new access pattern is now in production, and you absolutely have to put an index in place. But again, maybe 10 years ago when you were designing a schema, you didn't even know that this access pattern would be there, right? So this table was added half a year ago, and now we need to add an index there. It happens, absolutely. This probably speaks to the need to test with real data. One thing that I see a lot is a really small development database. We have 1,000 entries there, and we run a query, and maybe it does a full table scan, right? But it's fine, it's 20 milliseconds. Then in production, there are a million records, and it does not run 20 milliseconds, right?
Yeah. You think about it from the let's pick Amazon for instance. It's like testing on a Sunday morning at 3 a.m., like that type of workload versus, your Black Friday or your, Prime Day that just happened, like workload. Very different workloads and probably very different needs and requirements on how much data is being accessed when, right? And so I think that's a very valid point that, testing with production-sized workload is important. Now, are there any tools that you've seen people use? Because honestly, testing applications at scale is a challenge in and of itself, especially on the database side. I know that there's some testing tools that you can do to replay query workload, but what's your experience in doing that sort of like testing? Jobin, why don't you start with an answer?
More
start
than
there.
a simulated test environment, what we love to get is the real workload data. So like Sergey mentioned about a logmin duration statement by which we capture actual the queries which is executing in the system. And if you look at the new versions of Postgres, that is the area which is getting improved a lot. Now we have provision for sampling the queries at different levels. Say queries which is taking more than 100 millisecond. I want a set of samples of those queries. I can configure such a way the parameters, and we'll get those queries. And even Postgres provides ways by which we can look at the explained plan of those things behind the scene. So we have real data, real performance data coming out of real production environment, and that gives the real picture. So where the things are getting slow or repeated. Say we need to look at multiple aspects. There could be a query which is very very fast, but it could be executed multiple times, say millions of times repeatedly. So an index on that will give huge benefit. But if there is a very complex query, but if it runs in as part of a month-end report, we don't have a problem there from the business perspective or from the yeah.
But how do you replay that workload? How do you test those queries? Like, how do you, like test that in a test environment?
Yeah, see, we request the end user to get those information, like the analyze information, explain, analyze information about those things. And we have Postgres related tooling like a PG Badger reports, which actually parses the Postgres log file and prepares sample with bind variables, everything. We can just pass it to customer. Okay, this is where we see the problem. Please prepare this, explain, analyze, and show us. We can help you to improve. Yeah.
Yeah. Sergey, any thoughts on query testing or replaying query workload?
It's difficult. Like, I'm not a big believer in the query replay field. I know there are quite a few tools in MySQL field, and Oracle has a query replay capabilities, right? It can record the workload and replay it and give you a nice report. But the problems there is that most of those tools, as far as I can tell at least, they do not respect the concurrency of the queries, right? You do not get the full you cannot replicate how exactly those queries hit your database, right? And what was the concurrency. In the worst case, they're just executed serially one after another, right? So that is completely unrealistic picture. What I think is like a good approach could be maybe through, like, I believe a lot of testing is being done, like QA and automatic testing for applications is a part of pretty much any development process right now, right? So I do believe that at least as one part of that, there should be, I'm not saying that there should be exactly the query, like the queries from production, like the amount of queries from production. I'm more towards that there should be a database, a size, and data distribution of production, right? So you should probably concentrate on either taking your production data and masking it and like creating maybe a sample of it right? If you like have a gazillion databases, every one of which is really huge, you probably should not be replicating that environment. But if you like have 100 gigabytes of data in production, you could probably replicate it and mask it and maybe hash everyone's names, right? Of course, do not violate GDPR. But then you test and you run queries and you see, like with a new release, whether maybe a new query appears in your query audit that was not there before, or that is now like executing for 2 seconds instead of 100 milliseconds, right?
Yeah, and this is where it's interesting. So, there's this nuance, and you mentioned like the QA testing and stuff. So I see a lot of companies that skimp on scalability testing or stress testing their systems. So, they'll run through like their test suite, and it will run through like a functional test where it tests all the functions individually, but it doesn't actually stress test the system, which means you never see the concurrency you mentioned. But even if you do have a large data set, the likelihood of you running through and just choosing like, a single string of functional tests actually doing anything that's going to move the needle on the database side to find performance issues is very minimal.
Yeah, absolutely.
Now, those that do stress test typically focus on the application. And here's a fun fact. I've actually seen quite a few companies who will make their test suite, they'll stub out and they'll create a false database calls. So they'll make a call to an API that should go to a database, but then they'll just return the database record directly from that, and they'll always return the same thing, so they'll get a consistent result. So their tests won't fail, but they'll emulate the database.
Yeah,
so you never hit the database.
Yeah, that is, you are like leaving aside a pretty huge part of your performance testing. Like, that is probably not what you want to do.
I think part of the issue is, like from a developer perspective, they view databases as commodities in a lot of cases, and so it's a necessary evil. They would love it if it was just an API call in and out, and that's all they need to worry about ever. Everything else is handled behind the scenes. They don't care what database technology. They don't care what indexes. It's fast. My data's out. It's in. It's out. It's in. It's out. It's in. I think that that's kind of the nirvana state, and a lot of architects and developers treat the database like that, just a data store, right? And I think that causes some of these issues to manifest in production because you haven't thought through all those potential issues.
Right, it could be, but like if you have an SLA for like an API call of your application, behind that API call you are going to a database, you probably should include your round trip to a database and the query into your SLA, right? So if you are stress testing without a database, then what are you stress testing anyway? So
it's an interesting topic, and it gets really deep because you can peel the layers of this onion multiple layers deep here.
I don't think I don't think that you should be cutting behind. What I see sometimes is that the database is kind of isolated from the application, right? So the application is a user of database, but database kind of provides a service, like you mentioned, commodity, right? I don't think that is a good approach. Like a database, if a database uses a database, if the application is using a database, the database and the schema that application uses, it's probably an integral part of an application and should be treated as such. And that's just my couple of cents here.
All right. So, Sergey, one last thing. You have a book coming up. What's your book on?
Yeah, me and another colleague from support, Vinicius, we are writing a book. And the book, surprisingly, is not about PostgreSQL. Since I was learning MySQL here in Percona, and I had to pick up quite a lot of knowledge on MySQL, I got a chance to write a book that is called Learning MySQL. It's a second edition of a Mulder book. And as I was learning MySQL, I was able to apply that journey into a book form. And it's closing to the publishing date, which is sometime late in autumn. But it's a huge it's a huge project. Kind of writing a book is a kind of a bucket list item, that I
Right,
had, and I couldn't skip on that opportunity, and yeah, it made my COVID year much more exciting than it could be otherwise.
I understand that. So, Jobin, Sergey, thank you for showing up and chatting with me. Jobin, you've got, I think, 4 sessions from Percona Live that are online, or 3 sessions Percona Live online now. Sergey, I believe you have 2.
Yeah, right.
So you can hear Jobin and Sergey talk about, different Postgres topics, PMM, monitoring, all kinds of fun things. I would encourage you to check out Percona, the Percona Live website or our YouTube channel, where you can get all these videos for free. Take a look, watch them, learn with us. So thank you guys for coming on to the show today, and appreciate it.
Thank you.
Thank you. Have a good one.
All
See
right.
you.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.